Welcome to the YouTube channel GCS Solutions. This is lecture on mathematical model, a practical approach. Hi, I am Dr. Sunil from GCS Solutions. The agenda of this presentation is introduction, a quiz for you before I get into mathematical modeling process, then the actual mathematical modeling process, then mathematical modeling steps, and then we have some real world examples, that is real time examples. Introduction. Now, what is mathematical modeling? What do you think? What is mathematical modeling? In simple and practical terms, mathematical modeling, I abbreviate as MM, is a representation of real world problems or real world scenarios in terms of mathematical expression. That means you are going to take real world problems or real world scenarios and you try to depict those real world problems and scenarios in terms of mathematical expression. Now, question is what all the domains are included in the mathematical modeling representation. So there are so many domains like science, finance, management, engineering, medical, banking, and so on and so forth. So these are not the limited domains. Mathematical modeling is basically applied on every aspect of life, whether it is a real world or technical world. Now my question is, how many of you have not used mathematical modeling? I say not used. Now we are going to answer this query very soon in the subsequent discussion. Before I start exploration on mathematical model or mathematical modeling, a quiz for you. Quiz question number 1. Who was Blaise Pascal? A French mathematician, physicist, inventor of mechanical calculator, philosopher and writer. So what is your choice? Perhaps you may have different choices. Like someone may say option 1 is correct, option 2 is correct, or 3 is correct, or 4 is correct, or 1 or 4 is correct. What do you think? I pause a while, think, and then tell. The answer is all 4 options are correct. That means Blaise Pascal was a French mathematician. Do remember he was a mathematician. Physicist, inventor of mechanical calculator. Imagine a person of a mathematics stream invents calculator. Then philosopher and writer. Quiz question number 2. Who was Charles Babbage? English mathematician, philosopher, inventor and a mechanical engineer, originator of digital programmable computer. So many of you may give 4th option as the correct one. But I again pause a while and let you think. What do you think? The correct answer is all 4 options. Charles Babbage was English mathematician. A person who is mathematician is also a person who invented digital programmable computer. So he was a philosopher, inventor, a great inventor, and a mechanical engineer for your surprise, and invented programmable computer. Third question. Who was Betty Hallberton? Who she was? An American journalist, creator first generative programming system, that is the creator of first generative programming system, chief of programming research branch applied mathematics laboratory at David Feller Model Basin in 1959, and developer of COBOL and Photon. What do you think? Again, all 4 options are correct. Now, what was the purpose of giving this quiz to you? The reason is like those who are from different backgrounds, like someone of you might be from science background, might be from maths background, might be from engineering background, or mechanical engineer, or computer engineer, an IT engineer, or so many other streams. But question is, how many of you are able to present your concepts in terms of mathematics? And question is, who are the people can ignore this mathematical representation of the technical or real world problem? The answer is none of these people can ignore. Mathematical modeling is equally important to science, to mathematical background people, as well as for the engineering background people, and even the people from the other domains. So I hope that you understood the significance of mathematics in the life, real world life as well as technical life. Mathematical modeling process. Let us now try to explore on this mathematical modeling process. So in general, we have a real world problem, always a real world problem. That real world problem, if we work on it, we get a real world solution. So obviously, if we have a problem, we try to find out a solution for that. But question is, can I represent this real world problem into mathematical world problem? Yes, of course. Now, what all are the steps to convert the real world problem into mathematical problem? The steps are very straightforward and simple as well. The very first thing you have to do is that take a real world problem, consider it as a mathematical problem. That means you have to do certain assumptions. Okay, that means you are going to model a formulation for a real world problem. So for that, what you do, you try to understand this real world problem into a mathematical problem, and you make some assumptions to formulate the mathematical problem in such a way that it will be represented as different equations which can be solved further. Obviously, if we have a mathematical problem, we have certain equations, we have certain formulas, and we always try to evaluate those formulas and equations to get some result. So the overall purpose of representing the real problem is to put it in terms of formula or equation. But before that, we have to first understand it as a mathematical problem. We have to make certain assumptions. With those assumptions and some mathematical notations, we formulate the equations for the real world problem, which is considered as a mathematical problem, and then we try to solve the equations to get some result or solution. But one may not stop once solution is achieved or you have got solution. What one need to do is to interpret the solution and see whether that mathematically interpreted solution is really matching the expectation of real world solution. Because whatever solution we got through mathematical modeling, is it matching the real world solution? If answer is yes, your process stops. That means what you have done is that you have started with the real world problem, you have converted that problem as a real world problem as a mathematical problem, you have made some assumptions, you have formulated the equations for those assumptions, you have solved the equation, you got the solution, you interpreted it, and that interpretation is correct as per your real world solution. But what if interpretation is not matching to the expectation? Then you basically compare your data of this mathematical world solution to the real world solution. If it is not matching, you try to refine the model. That means you again look back to the assumption steps, you reformulate your assumptions, and then again you reformulate the equations, you again solve the equations, and then try to get a new solution. Once that solution is up to the expectation, your process stops. So this way you perform the mathematical modeling. Now we'll try to get some real world problems as a problem to be solved, and then we'll try to apply these mathematical modeling steps on the problems. And mathematical modeling steps. These steps are, the 4 steps of mathematical modeling are, that is formulation of problem, that is making the assumptions, then formulate equation for solution of the problem, then solve those equation or equations, and then interpret and validate the solution. If your solution is correct, then process stops. Otherwise, you have to again step back to step number 1, then 2, then 3, then 4. This way, this cycle repeats. Now, let us try to understand each of these steps. That is formulation of problem, that is making assumptions. In this step, what do? You try to understand the given problem specifications. Then you try to convert it into mathematical representation. That means you are given a problem and its specification, and then you try to convert that problem specifications into mathematical representation. This is your first step. What is the next step? That is the second step. Formulate equation for solution of the problem. In this step, what do? Understand the task as a logical steps to be solved. So whatever mathematical representation you have done in the step number 1 of the mathematical modeling, you try to understand the task as a logical steps to be solved, then convert logical steps into actual mathematical format or form. Now, once the logical steps are converted into mathematical form, you try to solve the steps, those logical steps which are mathematical equations. Now you go to step number 3, that is solve equation. So in this, what do? You solve the given equation or equations which are formulated in the above steps. Once you solve the equation or equations, what do? You go to the next step, that is called interpret and validate the solution. So whatever solution you got in the earlier step, that is step number 3, you try to verify the equation by putting some real world values in it and see whether the solution is correct or not. If solution is correct, then you stop. If solution is not correct, then you iterate again to step number 1 and you again follow all these steps till you get a new solution. So pictorially it is represented like this. So just focus where I'm pointing. My laser pen is pointing now. So you do formulation of the problem, you solve the problem, then you interpret the solution, then you check and validate the solution. If solution is okay, your process stops. Otherwise, again you go for the formulation of the problem step and you repeat the cycle. I hope that you understood this. Now real world examples. So whatever steps we understood in the earlier slide, we will now try to apply those steps in any given real world scenario, or we will try to solve the real world problems using mathematical modeling representation. Now my first example is very simple. Find sum of the first and natural number. Now in this example, what do you find? What do you understand out with this find sum of the first and natural number? A simple problem. Is it a mathematical representation? No, it's an English statement. It's a very simple English statement. Yeah, no doubt there are certain mathematical terms involved in that English statement. That is, you have to find out the sum of first n. N stands for any value, that is first say 10 natural numbers, or say first 5 natural numbers, or first 100 natural numbers. So this is purely a English statement. Okay. Now, what I want to do, I want to convert this English like statement into a mathematical world problem. Now, what I do now, I apply 4 steps. Step number 1, make assumptions. So what assumption I do in terms of mathematical notation? So I use S as a set. That is, S stand for a set. What that set is? A set of natural numbers. Now what that set comprises of? It comprises of all the positive and negative numbers. Say for example 1, 2, 3, 4, -1, -2, -3, -10, -15, and so on and so forth. Now my set S has all positive and negative numbers. Now, as per the given problem statement, I have to make some further assumption. And what I do the formulation of the equation to find the sum. So here mathematically the sum is 1 plus 2 plus 3 plus 4 plus up to n. Suppose I want to find say a sum of first 10 natural numbers, assuming the numbers are positive and considering only positive numbers, then I have 1 plus 2 plus 3 plus 4 plus 5 plus so and so forth up to n, up to 10. Now I will try to solve this equation. Now you know that this summation of the numbers from 1 to n can be represented as a mathematical equation. So what that equation is? That is summation of I equal to 1 to n I, and that can even be expanded as 1 plus 2 plus 3 plus 4 plus up to n. Suppose my n value is 10, then obviously the summation will be the addition of first 10 natural numbers, positive natural numbers. Now I can even further evaluate this expression as n into n plus 1 whole divided by 2. So for this purpose you need to have some background of statistical mathematics. So I hope that you perhaps have a background of that, and with that assumption I directly put this summation of I equal to 1 to n I as n into n plus 1 whole divided by 2. Now I will try to verify this. So I have left hand side and right hand side interpretation. Now I take n equal to 5 for simplicity. So my left hand side will be 1 plus 2 plus 3 plus 4 plus 5, and that summation will come out to be 15. What of RHS? That is n into n plus whole divided by 2. So it is 5 plus 5 into 5 plus 1 whole divided by 2. That is 5 into 6. That is whole divided by 2. That is 5 into 3, 15. So what do I get here? I get a correct interpretation and I validate the solution. So this proves that whatever interpretation I have done is correct, and also whatever steps I formulated for the given problems are also correct. That is, left hand side equation is equal to our right hand side equation, and those are equating correctly with some real world value. I hope you understood this. What of writing this, putting this into a computer program? I know that computer engineers are very comfortable with representing everything in terms of program, because they are very much familiar. They are, I mean to say, they are frequently doing programming. So because of that, what they are habitual of are taking the problem and thinking over it and writing the program directly. But once they are asked to do mathematical formulation, it's a bit difficult for them, but it's not really difficult. Now we'll try to put this in terms of a simple program. So I have this programmatic steps. I have a variable n with value 5. I have a variable sum which accumulates the sum of the numbers, first 5 numbers from 1 to 5. So I have one loop for I equal to 1. This loop iterates till n, that is 5, and each time the iteration value is incremented by 1. And I say sum equal to sum plus I. So it's very simple. When I is 1, initially sum is 0. That will be it will be 1 plus that is 0 plus 1, 1. When I is 2, it will be 1 plus 2, 3. When I is 3, it will be 3 plus 3, 6. and this way that sum will be 15 at the end. So this is the mathematical representation and this is the computer program. So is it so hard? No. I hope that you perhaps are now comfortable with taking the example, real world example, as a real world problem, converting it into mathematical world problem and getting the solution and then writing a program for it. Next example is print array of order in cross n. This is very simple. Now in this problem statement, there is no maths involved, in the sense that this English like statement doesn't have any mathematical sort of representation except n cross n. Okay, so what is that n? N cross n, that is the order of matrix. If n is 2, it is 2 by 2 matrix or 2 by 2 array. Okay, now what I have to do here? I have to first understand this problem, real world problem, which is expressed in terms of English sentence. Then I have to follow the first step of the mathematical modeling, that is make assumptions. What is that assumption? First assumption, I have a set A or a matrix a 2D array of n cross n with some values, and that values, that is val. Val in general, it is value. It can be any value. It can be 24, 2500, 1000, minus 156, any value. Now I formulate equation. So how do I formulate equation for printing the array of order n cross n? So I have to consider now that array as a two-dimensional matrix. So here I have depicted that. Just focus where I'm pointing now. So I have certain rows and columns representation. So this is my first row, second row, third row, fourth row, fifth row. If I assume that my matrix, my array is of order 5 by 5, so my n value is 5. So I have 5 by 5 matrix. So 1, 2, 3, 4, 5 columns. So this is first row, first column. So 1 comma 1, first row, second column, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. And for column I have first row, first column, second row, first column, third row, first column, fourth row, first column, and fifth row, first column. So this is my actual mathematical interpretation. How do I convert that in terms of certain mathematical expressions? So I use for loop notations of the programming language. So for I equal to 1 to n, so I is my row loop and j equal to 1 to n, do this j is my column loop. And what do? I print val at every row column position. So when I is 1, it is row 1, and j is 1, it is column 1. So it will print first row, first column value. When my I is 1 and j is 2, it is first row, second column value. So this way, this equation which I formulated here in terms of semi-mathematical statements can be easily used for printing the values of matrix or array of order n by n. So I solve the equation. So I take value for I equal to 1, j will be varying from 1 to n. If n is 5, it will be varying to 1 to 5. For I is 2, so j again will be varying from 1 to 5 if I assume that my n is 5. Here what I'm trying to tell you is that you solve the equation assuming n as a 5 and you go for printing for each row all the column values. So this way I have solved the equations. Now I interpret it. Now if I take n as a specific value 5, then I have I varying from 1 to 5, and for each iteration of I have also a j value varying from 1 to 5. That means for each row it prints all 5 column values. So this way what do I have? I have a 5 cross 5 matrix with 25 elements which will be printed. And here also if we see with manual method, that for each row I have 5 values and I am printing all 5 rows. So I am getting 25 values printed. So this way I am trying to represent my real world problem to mathematical problem. Now what about the program? Very simple. I have an array of order n cross n. So array of size n by n. I use for loop, outer for loop for say row counting, inner for loop for column counting, and just print it. Isn't it a simple task? Yes, it is. My next example is print sum of a number for n number of times. Now this problem is little bit clumsy. Yes, still we'll try to uh, make it simple. What is expected from this problem statement is like you have to take, say, n numbers, sorry, a number. For example, I take a number 3 and I perform a sum of number 3, say 5 times. Okay, and this I will repeat again for 5 times. So this way I have to take this as a problem and I have to solve it. So what do you do for this? So again, follow all the 5 steps. So I have any value, any numeric value that I call it as a val. So this is all assumption. So in assumptions, you can have certain notations, alpha, beta, theta, or some variable notations, A, B, C, D, or something like this. Or you may have even long names of the variables or notations. So here I use n, that is number of times the sum is performed, and that sum is repeated as well. So I have sum of sum initially 0, that is the outer summation, and sum of numbers, that is the inner summation. What I am trying to do, I am trying to perform the sum of a number n number of times, and each time whatever sum I got for that particular number, I am again summing it to sum of the sum. So these way I have interpretation. Now what is the formulation of the assumption in terms of equation? So it is summation of I equal to 1 to n, again summation of j equal to 1 to n val. So what you are trying to do, you are trying to take a value, add it n number of times, and whatever sum you get of the numbers, you are again summing it for n times. So this overall the problem. So what I have tried, I have tried to put this problem smartly in terms of mathematical representation. Now I can solve the equation. So I have this sum of sums for summation of I equal to 1 to n. So inner sum is nothing but j equal to 1 to n, that is val you are summing how many times, n times. So val how many times, n times, and whatever sum you are getting, that again you are summing how many times, n times. So it will be sum plus sum plus sum up to n times. So it will be n into sum. If we try to mathematically do that, it will be n into sum, something like this. So we'll try to justify it. So interpret the and validate the solution. So I have val equal to 2 and n value as a 3. So what is summation of val 2 for n equal to 3? That is 3 times, it will be 6. And what is sum of sums? Sum of sums n times, so it will be 6 plus 6 plus 6. That means whatever sum I got of a given number, that I again sum how many times? 3 times, because my n value is 3. So it is 18. Now how about the right hand side expression here? If you see where I'm pointing now, if I have a value 2, it will be sum to 3 into 6, that is 18. Is it okay? What of writing the program? Writing the program is again simple. I have, for example, val 1, because I take value as 1, and number of times I want to add that value 1 is 5, and again I have to sum that num sum how many times, n times, that is 5 times. So sum of the sum is 0, sum of the num is 0 for I equal to 1 to n, for j equal to 1 to n. Sum of num equal to sum of num plus val, and sum of sum equal to sum of sum plus sum of num. Now I hope that you understood this, and you just try to solve this problem uh, on the computer. It's very simple. You can take these steps as it is and can put it in your program, and can in any programming language, and can solve it. Okay. So is it so hard to take a problem as a real world problem and convert it into mathematical problem and then write a program for it? Is it so hard? No. Next example. Now here I have a little bit a real world sort of scenario. In an institute, there is a class of n students. Now what task has been given to a student is segregate male and female students of a class into two categories, that is male category and female category. This is a purely an English statement. Can I formulate this as a mathematical word representation? There's a problem with mathematical uh, word representation. Yes, of course. Again, I have to follow the 4 steps. Make assumption. So I have made certain assumptions. S is my set of n students in the class. Suppose there are 100 students in the class, so S will represent all 100 students. M, that is set of male students in the class, which is initially an empty set because I am not sure how many students of the 100 are male and how many are even female also. So I have again one set of female students in the class. For that, as initially set is given value 5, that means empty set. Why? Because I have only a class with certain students. I am not sure how many students are male and female unless and until I physically see and count and note it down. I hope that you understood. Now, can I formulate this problem statement into mathematical equation? Yes. I have a set of students, that is Si, I varying from 1 to n. Now, for example, there are 10 students in the class, so my S1, I is 1, then S1 is the first student. When I is 2, S2 is the second student. When I is 3, S3 is the third student. So this way I have 10 students. Now what of set M? Set M has elements Mj such that Mj is a member of set S and gender of the Mj is male. Now again I have element Mj. Now what this M is? M is a set of male. Similarly, I have a set of females as well. So Fk. So what this Fk is? It is a member of the original set S, that is that female candidate is a student of that particular class and gender is female obviously. Now to make you understand this, I have here the pictorial representation. S is my set with say n equal to 10. So my S1 is a student with male gender, S2 is a student with male gender, S3 is student with the female gender. This way I have all 10 students present. What I have to do? I have to segregate this into male set and female set. So what I do here, I solve the equation for segregating this given original set having students with male and female gender together to a representation which will give me male student separate and female student separate. Here I have a first member of the male set, that is student number 1, student number 2, student number 3. Is it? No. Student number 3 is female. So actually student number 4 is male, but third student of my male set is here again a male. If you see this carefully, I have tried to put up these things more mathematically. So my third student is fourth student of the class. That is, I mean to say that my third male candidate of this set is a fourth student of this class. This way. So can I write a small equation for this? Yes. So what I do for segregating this original set into male and female, I have every S which is a member of original set S. If gender is male, then add that student in the male set, otherwise add that student in the female set. It's very simple because I have only two genders in the class, male and female. If I have one more gender, that is transgender, then I will have to have one more set. But here I assume that my class has only two students, as two category student, that is male category and female category. I hope that you understood this. Can I write a program for this? Yes, very simple. I have three sets S, M and F. As for set of students, original set, M is a set of male students only, F is a set of female students only. Now initially JK is 1, and what I do for all these students 10 students of this class. If the gender of that particular student is male, I add that particular student to male set and I increment the male index. Otherwise, I add the student to the female set and I increment the female index so that I can add the next female or a male. I hope that you understood this. So this is the way you can take the problem and can put it in terms of mathematical expression and can write a program for it in terms of computer problem. I mean to say in terms of computer uh, relevant solution. Now here is the end of mathematical modeling process. Dear learner, how was the lecture? Please subscribe GCS Solutions. Like the video if you really like it. Share among the friends if you find it useful and comment for the improvements. We are GCS Solutions, making technology easy to learn. Till next lecture, be a mathematician.